All right, what's going on, everybody? We're moving on with chapter 6, brand new chapter. Chapter 5, we just finished up on triangles. So naturally, chapter 6 is going to be on quadrilaterals. Triangles have 3 sides, quadrilaterals have 4 sides. Today, specifically with lesson 6.1, we're going to be talking about interior and exterior angles. Just like always, before we get going, just a reminder, you can always go into Canvas here on the homepage. It says period 5, but they're all the same. I have now uploaded, I'm working on the first chapter 6 lesson video, so it's not there, but the chapter 6 notes and the chapter 6 slides for 6.1 are up and available. You can find them there on Canvas on the homepage. Okay. Our objective in this lesson is to find and use the measures of interior and exterior angles of regular and irregular polygons. So what is a polygon? A polygon is a flat-surfaced figure formed by 3 or more line segments and sides only intersect at vertices or a vertex or a corner. Okay, they cannot ever cross each other. So we see here's an example of a polygon, right? It doesn't matter how many lines it has as long as it's flat surface and they all connect, and they connect at all of these vertices or vertex or corners, right? This is not considered a polygon because it's not closed. It has this open space here, so it can't be identified as a polygon. And here, this also is not a polygon because we see that the lines cross each other, right? They do not intersect at vertices. They intersect here at an intersection, right? So here is your only example here of a polygon. Okay, convex versus concave. Convex, all angles point outward, and concave, at least one angle points inward. Think about the word cave. A cave, you go into a cave. So concave means that it points inwards. Okay, when we classify polygons, we always classify polygons by the number of sides they have. So here's a bunch of names for different types of sides, right? 3 obviously is a triangle. This chapter we're talking about 4 sides, which is a quadrilateral. 5 sides is called a pentagon. 6 sides is called a hexagon. 7 heptagon. 8 octagon. 9 nonagon. 10 decagon, and 12 dodecagon. Right, and any other numbers, although there are proper names for some other sides with different numbers, right? To a certain point, whatever the number of sides is, we would call n. We'd use it as a variable, and we would just call that an n-gon. For example, if the shape had 13 sides, we'd call it a 13-gon. If the side had 112 sides, we'd call it a 112-gon. Right? We would just use that number and then just add the word gon. Or I guess it's the suffix gon to the end of it. Okay, interior versus exterior angles. This seems pretty self-explanatory, but the interior angles are the angles inside of the shape or the polygon. The exterior angles are the angles outside of the polygon. However, it's super important that you realize that the exterior angle forms a linear pair with the interior angles, right? So if we take a look here, right, the exterior angle has to form that linear pair with the interior angle, right? If this line were to extend, right, this is an exterior angle here, this is an exterior angle here, and if I change it to red, right, this here is not an exterior angle because this angle does not form a linear pair with the interior angle, right? So that is a difference. So interior angle is pretty obvious to tell. Exterior angle, there is a little bit of a discrepancy between what is actually the exterior angle. Okay, interior angles in convex shapes. Okay, so a diagonal is a segment that joins 2 angle vertices, right? So if you draw all possible diagonals from only one vertex, if we go in here at this corner or this point A in this shape, we can draw a diagonal, right, connecting all of the other vertices except for 2. And the reason why, if you think about it, right, this line right here, right, that's not a diagonal because it's literally just a side of the shape. This line right here, right, we can't create a diagonal because that's literally just part of the shape. We notice that all of these blue ones cut across the middle in some way, shape, or form. Okay, so if you notice, we see that all of these shapes of the diagonals, we have now created a bunch of triangles within our shape. All right. And since we just got done with the chapter of triangles, we know that the angles of triangles are always going to add up to 180 degrees, right? So if we think about this, we know that this triangle has 180 degrees. We know that this triangle has 180 degrees. This has 180. This has 180, and all of them have 180, right? We just got done with the lesson of the chapter of triangles, so we know that. Okay, so using this piece of information, you can then tell and see how many degrees make up all of these angles on the inside of your shape, right? If you just take 180 and multiply it times 1, 2, 3, 4, 5, 6, right? You do 180 times 6. We see that 6 times 0 is 0. 6 times 8 is 48. We carry the 4 there. 6 times 1 is 6. Plus that 4 gives us 10, right? In this shape, the interior degrees are going to add up to 1,080 degrees, okay? And that is how you can know and tell how many degrees are inside of a specific shape or a specific polygon that we have. And that's essentially what this chart is going to have with us, right? We know that a triangle has 3 sides. We know there's obviously only one triangle in a triangle. And we know that all triangles add up to 180 degrees, right? So if we take all of these other shapes, okay, this shape with 4, right, you would fill out that this is called a quadrilateral. And now I really wish I would have left this filled in rather than having to write it poorly with my mouse. But if you, again, draw all diagonals that are possible, right? Remember, you have to start at just one corner. So if I start here, I can't draw there because that's just a side. I can draw there, and I can't draw there because that's just a side. So now I have created 2 triangles, which means that 2 times 180 means that for every quadrilateral, there's going to be 360 degrees in the angles. If you add together all 4 angles of a quadrilateral, it's always going to be 360 degrees. Okay, and if you go on and do the others, right, let's take a look. You have to start at just one. Can't draw there. I can draw there. I can draw there. Cannot draw there because that's just a side. So now, number of sides with 5, these are called a pentagon. We see that we have created 1, 2, 3 triangles here, which means that 3 times 180 is going to end up giving us 540, right? 540 degrees in all shapes with 5 sides, so on and so on and so forth. If you notice, maybe you can see that we have created a trend. 1, 2, 3. Even without doing this, I bet you this is going to end up being 4. This is going to end up being 5. Okay, and then if you scroll back on the previous slide, right, you see all of the different names of the different shapes. We see that a 6-sided shape is called a hexagon, and a 7-sided shape is called a heptagon. And let's see if I was right? I bet you that the pattern would continue. Okay, so let's take a look. You start at one side, can't draw there because that's a part of it, right? We draw there, we draw there, we draw there, and we can't draw there because that's a part of the slide. We see that we have 1, 2, 3, 4. Look at that, the pattern continued. And if we start here, can't draw there, we draw 1, 2, 3, 4, and can't draw there. So we have 1, 2, 3, 4, 5 triangles, and see the pattern did in fact continue. So then we can see that the sum of the interior angles here, we just keep going. Sorry, that should be 4 times 180. Here, let me erase that because that looks really bad. 4 times 180. And again, I'm going to use my calculator here. So 4 times 180 gives us 720 degrees, and 5 times 180 is equal to 900 degrees, right? So that means you can always figure out how many degrees are in whatever side, whatever shape you want if you know how many sides are in it. So let's see if we can see the pattern here, because n, remember now n is being represented as a triangle, okay? So let's take a look. What is the difference between the number of sides and the number of triangles? Well, if we had 3 sides, that made up 1 triangle. 4 sides had 2 triangles. 5 sides had 3 triangles. 6 sides had 4 triangles. You notice that the pattern is that whatever the number of sides is, you're going to have 2 less triangles, right? 4 minus 2 gives you 2. 5 minus 2 gives you 3. 6 minus 2 gives you 4, so on and so on and so forth. So if we have an unknown number of sides and we just label it as n, that means the number of triangles is going to be whatever n is minus 2. And if the sum of the interior angles was always 180 times however many triangles there were, that means even if we don't know how many triangles there were, we can still represent it with n minus 2. And whatever that is going to be multiplied by 180. And that there, ladies and gentlemen, ends up being the equation of how you can find out how many degrees are in any shape with however many sides you end up having. You just plug in, you count out the number of sides and plug that number in for n and subtract by 2 and then multiply times 180. And that will always tell you how many degrees are in any shape. Okay, and that is then what our formula is, the sum of interior angles of a convex polygon, right? When n is the number of sides, you just plug in the number of sides in for n, subtract 2, and multiply it times 180. So we see here that we counted up. We have 1, 2, 3, 4, 5 sides. Luckily up here, we already found out how many degrees are in a 5-sided shape, but let's just go ahead and continue and use our formula. So if we do 5 minus 2 times 180, right? Remember, these are parentheses, so you have to do that first. This just ends up becoming 3 times 180, which we know is going to end up being 540. So that means in all pentagons with 5 sides, the interior angles is going to be 540 degrees. And as you can see, it's very similar to what we did last chapter with triangles. You know that all 5 of these angles have to add up to 540. Luckily, we are given 4 of them. So you're just going to set up your equation similar to how we did with triangles. We'll have 100 plus 125 plus 89 plus 105 plus, sorry about that, plus x. And we know that all 5 of those have to add up and give us 140. All right, so I'm going to use my calculator here. 100 plus 125 plus 89 plus 105, all of those combined, right? If you add up all of those, that ends up giving you 419 plus x equals 540. And then if we subtract 419 from 540, we end up getting that x is equal to 121 degrees. So we know that this angle here could be 121. Okay, now exterior angles, your equation that you're always going to have is that for all shapes, no matter how many sides there are, the exterior angles will always add up to 360 degrees. So in this example, we have a 4-sided shape, right? We know that the interior angles of a 4-sided shape add up to 360, but the exterior angles of a 4-sided shape also add up to 360. The exterior angles for any shape, even if it's a 5-sided shape. So if we were to take the exterior angles of this shape, right, we would still, and we added up all of these, even though it has a different amount of sides, it's still going to add up to give us 360. So that means it's a similar way we set up this equation. We add up all 4 of these, and we know that it has to add up to 360. So 78 plus 80 plus 90 plus x. Sorry, that's written very poorly, but that's plus x is equal to 360. Okay, and again, I'm going to use my calculator, but 78 plus 80 plus 90 ends up giving us 248. So that means 248 plus x equals 360. We subtract 248 from 360, and we get that x is equal to 112 degrees. Right? So we would know that this one is 112. Okay, so these are your two formulas. I guess this one's not really a formula. It's something that you should know, that all exterior angles add up to 360 degrees. Okay, so some examples. Find the sum of the measures of the interior angles of each type of polygon. Right? So remember, your equation for finding the interior angles is always n minus 2 times 180, where n is the number of sides. All right, if we have a heptagon, remember you can even scroll back and look at your shape. A heptagon has 7 sides. So that means to find out how many degrees are in a heptagon, we simply just do 7 minus 2 times 180, which ends up being 5 times 180, which ends up being 900 degrees. Okay, an octagon, if you scroll back, has 8 sides in it. So 8 minus 2 times 180 ends up being 6 times 180, which ends up being 1080. Right? So that means for any 8-sided shape, it will always have 1080 degrees. And then remember, a 13gon, it has obviously 13 sides in it. So if 13 is n, 13 minus 2 times 180. All right, that gives us 11 times 180, which ends up being 1,980 degrees, right? So there's obviously, with bigger shapes that have more sides, you're obviously going to have a lot more degrees in them. Okay, find the measure of angle E if the measure of A is, so here, let's fill these out, right? A, it tells us, is 160. B is 50. C, the measure of angle C is equal to the measure of angle D, which is also equal to 140. So that means both of those are 140. That was a weird way for that to be phrased, but we are smart and intelligent, so we know that those are 140, and we don't know what E is, right? So I guess instead of a question mark, we can write an X there. Okay, so first, we need to figure out how many sides there are. There are 1, 2, 3, 4, 5 sides. We already have done this equation, but remember, you could do 5 minus 2 times 180 to find out how many degrees. We know that that does end up equaling 540. So that means we're going to add up all these 5 angles, and we know that it has to add up to 540. So we would do 140 plus 140 plus 50 plus 160 plus x is equal to 540. And again, if we use the calculator, 140 plus 140 plus 50 plus 160, all of those combined give you 490. So all of those combined give you 490 plus x is equal to 540. And then if you subtract 490 from both sides, all right, that'll cancel out, and you end up with x is equal to 540 minus 540 minus 490 ends up giving you 50. So we know that that angle is going to end up being 50 degrees. Okay, over here, find the measure of angle 1 if the measure of angle G is 80, the measure of angle F is 110, and the measure of angle H is 74. Okay, so 2 different ways you could go about finding this. If we're looking for angle 1, right, that means it's an exterior angle. So different ways that we could do this. We could either make all of these exterior angles, right, and we could find all of these, and we know that all 4 of these would have to add up to give us 360 degrees, right? And we could find this by subtracting 180 from 74, subtract 180 minus 110 to find that one, 180 minus 80 to give you that one. Or another way, because we know that this is a quadrilateral and all 4 of the interior angles have to also add up to 360. Personally, I think that would be easier because we already know what these numbers are. So that means to find the blue angle, we would have to add together 74 plus 110 plus 80 plus x to equal 360. And again, if we add those up, 74 plus 110 plus 80 adds up to give you all three of those add up to give you 264 plus x equals 360. All right, if you subtract, then you would get that x is equal to 96. But remember, that's the blue angle. That's technically not what we're looking for, but it's helpful to help us find what we're looking for. All right, so if this one is 96, now we see that these create a straight line. Straight lines always measure 180 degrees. So here we could just do 180 minus 96. Right, you got to borrow there. That gives you 7. 10 minus 6 gives you 4. 7 minus 9, we got to borrow again. All right, 17 minus 9 is 8. We see that now this pink angle here, angle 1 that we're originally finding, angle 1 is equal to 84 degrees. All right, so again, you have to find certain pieces of information before you can find what you're actually looking for. It's like a puzzle. You got to put all your pieces together. Okay, and those are all the examples I have. First lesson again for chapter 6. Come to class with any questions if you have. Go Mustangs.